Thank you for having me. I put together these slides maybe like, I want to say 2 months ago. And in the last day or two, I've been rereading them, fixing some things, trying to remind myself of all like the, technical details and stuff like that that I really got into. Um, so it will be a little bit of me reading off the slides, quite a bit, but I can answer a lot of questions. I didn't have a ton of time to practice it as I, normally would like a presentation, but I did give you a whole breadth of like detail. So hopefully, like if you get the slideshow afterward, it has all that information for you, and you should be really good with, knowing as much as you need to know. I will try to share now. I haven't done that before on here. Like everyone was saying, my name is Vincent Zamayoa. So as just an agenda, I'm gonna introduce myself in a second, but the general agenda will be an introduction, talking about open versus closed headphones, frequency response and their targets, the effects of impedance. A lot of the talk will be on driver types. A little bit will be on cable types and terminations. And there's a lot of content on different companies and technology. I really wanted to not only show, the different driver types, and that's a big difference between how different headphones, sound, but also different companies have taken those different driver types and they've said, oh, we're trying to solve this problem with this driver type or this thing, and we're trying to, and then another one will patent something else and try and solve something else. So I really wanted to dive into the companies and their different technologies. I very likely won't get through everything, but I did put it all together, and I will hopefully, be able to give everyone the slide set. I will stop after about probably about an hour wherever I get to, and then hopefully be able to do some Q&A. But at least all this information will be here. So like I was being introduced, I am an organizer, or the organizer and admin for Bay Audio Enclave. We have 515 members on Discord now, and it's still growing. We do regular meets, 2 big ones and 2 small ones a year. We have other events like, IEMs and coffee. Those are other types of meets that we might do. And we also have DIY projects, and then we also do loaner tours where different manufacturers will send us gear. And I usually set up a list of interested people and then organize that getting sent to different people to have a chance to listen to gear on your system, which is a really nice thing to be able to do. You can't do that so much with speakers, but you can do that with headphones. So like Laurie was saying, I'm a controls engineer. Because of that, I'm very interested in different technology. It definitely consumes the majority of my intrigue into different things. My goal of the presentation is to introduce you to different concepts that are usually part of discussions to describe headphones, to discuss the differences between the different headphones, including different chassis design, driver designs, and different driver implementations of technologies, and then to also familiarize you with different cable terminations, because unlike speakers, we have a few, and it's kind of frustrating. There are different standards now, but there are still quite a few. Oh, and also to give you, some awareness of the different popular companies, because there are quite a few. So to start this off, at the highest level, you can kind of characterize or generalize headphones into 2 big things: open or closed. And so you do have this kind of small category of like semi-open headphones. Those are a little more rare, and they're very hard to generalize. So I'm just going to skip over them as a topic, but they do exist. But generally speaking, you're always going to hear either an open or a closed. Now, open, the definition is going to be that you have nothing between the driver and your ear, and nothing behind the driver and outside. So usually you'll see the open backs will be quite obvious and open. But that's not That's not strictly true. A lot of open backs will also have damping on the driver side between the driver and your ear. They're still called open backs, even because generally now closed backs are just seen as like literally closed back. But open backs have a tendency to sound or have a much larger sound stage. They're much more like speakers in an open room. They also tend to show bass roll off, usually around 50 hertz. And then closed backs, like I said, they might have something in between your ears and the driver, and they usually and always actually have the cup closed. They usually have a much smaller soundstage. The rear volume can also be, smaller or larger. Large volumes could have a lot of dampening, but they can also be undamped, and that'll sound like a chamber, and that's generally not preferred. But there are a few that do, but they're generally rare. Oftentimes, this chamber in the back will have reflected back waves that'll cause, unwanted frequency response peaks and dips. Usually they use damping to try to mitigate this. But generally speaking, a lot of closed backs will have a mid bass bump and then some mid treble glare. Though the best closed backs have done a very good job at mitigating this. But as a generality, this is not true. You can hear a closed back and definitely tell the difference. Frequency response. So generally speaking, you will see either raw or compensated graphs. The frequency response graphs are useful in comparing the different tonalities between different headphones. So you can look at one graph and you can look at another graph and you're like, oh, this one will probably be more bassy or might have more treble. You can kind of actually see that on the frequency response graph, but they don't present things like technicalities like decay, attack, timbre, or soundstage. They do show you tonality, but tonality is different than timbre. So like I said, you have raw or compensated. The top right one is raw. You'll see like the little brown curve will be how the headphone actually measures. And then oftentimes you might see it compared to some reference, which in this case is the Harman 2018 curve. And so you'll kind of be able to compare, hey, if you compared to this reference, this is how this usually looks. And they're usually matched up around 1K. So around 1K, you can see if they match up. Usually when you have multiple lines on a frequency response graph, you'll notice that they're almost always lined up at 1K. That's just standard. I don't know. I mean, that's just standard. You'll also see compensated graphs. Compensated is usually the difference between whatever the headphone you're measuring and then the actual reference. And so what you're looking for there is you're looking for a flat line, generally speaking, because if you wanted the reference, you would want no difference from that to the reference. Now, you may not want the reference. That may not be your preference. So you may not want an actual flat line, but it at least gives you a point of comparison between that reference and then what it actually measured. So now on the topic of references or frequency response targets, there are a lot of different, there are a few different targets. A lot of targets, maybe a few years ago, would have been some version of the Harman target. You have the 2013 to 2018. I think there's a 2015 one that's quite popular. And you'll see, at least in here, that between 2013 and 2018, there's some differences. You'll often see, a Harman target. It was developed by Harman Research to identify what tuning most people might prefer in headphones. And it's definitely changed over the years. More recently, though, Harman's still used, but more recently in the conversation, we have this diffused field target, or in some cases, that same diffused field with a downward tilt, which means like a little warmer than flat. And that diffuse field target aims to emulate the way flat measuring speakers would sound in a somewhat lively room. I don't know what lively room means, but that's how it's defined. But you will see diffuse filled or diffuse filled downward tilted a fair amount in more recent like conversations. Another important thing I wanted to point out was anatomy and your HRTF. So a lot of times you'll have, and especially in public forums, you'll have this conversation about, oh, well, it measures this way, or it measures this other way, or, that sounds bad because it measures this way. But what's only sometimes spoken about is how, even though how it measures is objective, how we all hear things is not objective. It's very subjective. And so even though something measures something some way objectively, how you're going to hear it and how you're going to perceive it is very subjective. So shown here is how 30 different people with microphones installed just at a blocked ear canal. So it's not even including their full ear canal. And so it's just the head, the ear, and the pinna. And these are the measurements taken listening to the same thing. In this case, an Sennheiser HD800S. And so you'll see how different, you can hear bass. Generally, the mids are pretty tight. And then as you start to go to the mid, high treble or, treble region, upper treble, it spreads out quite a bit. So everyone will not hear the same way. So even though you might be looking for, hey, I want a flat, sounds like this, everyone's preference is going to be different. So while I always, will use measurements, it's a great way of understanding how headphones compare to each other. You can't really know how it's going to sound until you try it. And that's, I think, my biggest takeaway is a lot of people can have a lot of opinions about headphones and they might all be right because everyone hears differently. So it's really wrong to have discussions where you say, well, you're wrong because this is how it sounds or this is how it measures, because it may not sound that way to somebody else. Another thing that's really important is how these measurements are taken and the instrumentation used to actually take these measurements. So in the past, we were using a lot of the 711 couplers, which is this guy. And then it got upgraded to the Gross, which is this guy. Also things that impact it are whether they're flat plates. This one's more of a kind of an in-between between a flat plate and something that actually shows like the round curvature of your cheek. And then you have something that's a little more very, very intricate, where you have the full ear modeled. You'll even have how like squishy, I don't know how to describe this. If you feel your ear and you feel how squishy or hard it is, modeling that is quite important too, because if it's a hard piece, it'll reflect differently, or if it's a soft piece, it'll absorb differently. And then how the actual curvature of the ear and, basically the anatomy, and then the inside of your ear canal. Oh, and how big your pinna is, which I don't really see easily here, but anyway. And then you have a full head and torso simulator. So this is actually like the peak at the moment. It's the Brewing Care 5128, and it's $41,000. So it's extremely expensive. But that's kind of like the highest standard right now. And you have the full head and torso. So you simulating the cheek, you're simulating the whole head as a damping factor. You're also simulating the torso. And then you have this fully modeled ear and then the interior ear canal. But whenever you see these measurements, you also have to look at like, how was this measured? With what instrument was it measured? Because they'll all have different, it'll have a different effect on that measurement. So when you compare, different headphones one to another, you have to see like, oh, am I comparing it with the same measurement or instrumentation? Otherwise, you have to be aware of like, when this thing is measured has a tendency to dip here in this, area, or, it might have a peak here, which doesn't show in like another instrument. And then another type of thing you might see online, this is a little more rare, but I think it's really interesting, is CSD plots, the waterfall plots, or cumulative spectral decay plots. So this is a lot still like a frequency response plot that I showed you before. So on the y-axis on the left, you still have the gain, the magnitude, and then on the x-axis you still have frequency. But now in the rightmost y-axis you have time. So at the very back, you basically have the frequency response that you normally would see on a 2D plane, but now you see how it decays over time. And the most ideal headphone would decay all at the same time, so it looked like a waterfall. But sometimes they don't. Actually, oftentimes they don't. And that'll usually be because of some sort of ringing or something that's causing it to not decay at the same rate. Sometimes it's like materials or the chassis or something about the design. So you can see how well something decays at different frequencies. And that can give you an impression of ringing. So even if something doesn't peak, like it's not like really high treble, maybe you hear a lot of ringing that occurs, and that can be, you can see that in a CSD. And then last part about measurements, other things you might see is impedance over frequency. So some headphones don't have the same impedance over frequency. Oftentimes those are dynamics. Square waves, which tend to show you the attack and decay, how well or damp something is. Impulse, which is the same thing. It shows attack, decay, and damping. Those two are usually at a particular frequency, so it doesn't give you the full spectrum like a CSD will, but it does give you a lot of, you can clearly see what happens at that frequency. And then you have the total harmonic distortion, which tends to show you, how much noise you might have or is present. That's usually kind of important if you want to EQ. So the lower something has, the lower the noise of the thing, the more you might be able to like change it via EQ. Another point I wanted to make is I mentioned how impedance isn't necessarily flat. So oftentimes for dynamic drivers specifically, the impedance will change over frequency. The example on the top right is an HD 550. Now, this is one of the interesting things you could do with a varying impedance is you can kind of change your amplifier's impedance. I don't know if this is technically, or I don't think it's very often true for speaker amplifiers. I think the amplifier has a tendency to be a set impedance, but on headphone amplifiers, you can also have impedance switches. And so what you could do is you can change the impedance of the amplifier. And what that will do is it changes how it interacts with the headphone. And so in a theoretical, like high impedance amplifier, what could happen is you end up with more voltage because it acts like a voltage divider rule. You can end up with more voltage at a higher impedance at one frequency or a frequency range versus at a lower frequency or a higher frequency range where you have a lower impedance. And that will cause an obvious difference in your sound pressure level. So it'll sound as if the bass is higher. And that'll be a way of you being able to kind of modify with just your amplifier how something sounds. Is there anything else? I guess this one source of synergy, at least in headphones. You can have different amps with different impedance outputs, or you can have one with a switch. It's really useful, but it's also really useful to know how your headphone impedance over frequency curve looks like. All right, driver types. So dynamic, I think you guys are the most, I don't really think I need to go over a lot here, but the information's there. Obviously you have magnet, voice coil, suspension, diaphragm. The magnet and the voice coil and the diaphragm will be pretty much prevalent in every driver type. Suspension, not always. But almost all drivers you run a signal through the voice coil, and because of the magnetic field that's created and the permanent magnet, you end up getting piston-like motion. A lot of differences in headphones, other than technology themselves, will often be material choice. So the material of the magnet, the material of the voice coil, the material of the diaphragm, these are all very important and can lead to very big differences in sound and very differences in cost. Current trends for magnets are just the strongest, lightest possible magnet. Usually, if you want an extremely strong magnet, it has a tendency to be very heavy. So if you want a strong magnet that's not that, not heavy, you're going to pay a lot in cost and just material. Generally speaking, you want a stiff diaphragm. You don't want comb breakup and such. I mean, that's pretty common in speakers as well. You want a very small amount of mass because you want it to be able to react. So you don't want slow decays or attacks. You don't want it to be low sensitivity because you don't want to have to give it a ton of power in order to make sound. Dynamic drivers, at least in the headphone space, tend to suffer from bass roll-off, generally less microdynamic compared to planars, air motion transformers, AMTs, and electrostats. But they can also sound very punchy, very lifelike, much more what most people are used to listening to because dynamic drivers are so prevalent. And like I said before, dynamic drivers have a tendency to have an impedance curve, which is not constant through the frequency spectrum. So other driver types, orthodynamic and planar magnetic. So these are generally the same. It's easy to characterize them as the same. Generally, orthodynamics might be circular, and I'm showing the Yamaha on the top right. Generally, the Japanese tend to call their what we would call planar magnetics as orthodynamics. We have a tendency to call them planar dynamics, and at least over here, planar dynamics have a tendency to be ovals or squares. Well, mostly ovals. Well, it's not fair. But anyway, it's not important. Generally, the orthodynamics have a tendency to be circular. But at least the Yamaha's is very highly permeable, which allows air to travel through it. That's not generally true about planar dynamics. The bottom right, I'm showing the Hi-Fi Man planar dynamic. You still see the diaphragm, which is this film. You see this circuit, which is basically a voice coil, and that's etched onto the diaphragm. And so you still run a current through the voice coil, and that still creates a magnetic field, which, because it's etched onto the diaphragm, will interact with the magnet structure and will cause it to move back and forth. Generally speaking, you'll hear single-sided or double-sided, which is how many magnets it has, whether it's on both sides or one side of the driver or the diaphragm, sorry. Planar magnetics have a tendency to have very extended bass frequencies. If you look at frequency response graphs, they generally are very flat all the way down. Very fast microdynamics, but they could be quite heavy due to magnets, especially if you get double-sided planar magnetics. They have a tendency to be much heavier than basically any other driver type. And their impedance tends to be flat across the frequency range. So usually when you see a company list off their impedance, it tends to be at 1 kilohertz. And if you read that, whatever the value is for the planar to magnetic, you can pretty much believe it's that the entire way through. Electrostatics. So these drivers are 2 perforated metal plates, which are called the stators. And in this guy, it's this over here. And in this figure, it's these two. So they're on both sides of a thin plastic film. And that plastic film which is this orange line, is given a DC bias. So it's energized, but the current is actually run, or the signal is actually run through the stators themselves, and it's on a out of phase polarity to each other. So when one pushes, the other one pulls, and that will cause this diaphragm to move. Let's see, what am I missing? They're very, very thin. They tend to be, the actual diaphragm is very thin. They have a tendency to sound thin as well. They don't have a very full sound, at least not to me. Their bass has a tendency to roll off significantly. I've never really heard an electrostatic that has like you're not going to hear a bass head go, oh man, I love those electrostats. But a lot of them are quite neutral. They're extremely fast. They're highly resolving. And because that film is so thin, when you're moving, if you move it around in your head at all, you usually hear it. It usually sounds like foil. It goes, you know. Let's see. Oh yeah, and this is actually a very small space between them, so the film doesn't actually have to move very, very far, which gives it a very small amount of distortion, and yeah, like the fastest microdynamics. AMTs, so air motion transformers, they have a folded diaphragm. So you can kind of see it here, you can see it here. This whole plate is a diaphragm, and there is a conductor that's printed on top of the diaphragm. Can't see it here, but you see it starting here, but it's in the folds. And so what happens is, again, you run current through this conductor, and because there's a magnet on one side, and because you're creating this magnetic field with this conductor, it reacts to the permanent magnet, and you end up with these local push-pull. So instead of the diaphragm moving left-right, like pushing air, so the squeezing, instead of push-pulling toward you, it pulls toward each fold, and it tends to squeeze or pull the air back in toward itself, which is what gives you the sound pressure change, which is what the sound you actually hear. And then the air tends to move 4 times faster than the speed of the folds moving, which allows it to have very fast microdynamics. But AMTs have in the past had a lot of hard time reproducing bass, but recent offerings, I'll call them, have made very big strides in mitigating this. So last driver type I'm talking about are ribbons. Ribbons are ultra-thin conductive diaphragms, typically aluminum, that are placed between 2 magnets and secured at the top and the bottom. They're very, very similar to planar magnetics in the sense that it's, a conductive material placed between 2 magnets. But in this sense, it's not a diaphragm, which is non-conductive with an etched circuit on it. It's the whole thing is a conductive surface. So the whole thing is a diaphragm, and all of it is, in this sense, the voice coil. And then you run the current through the conductive material, and then because it's between the magnets, it moves or kind of flutters between the magnets, and that gives you your sound pressure change. They have tended to have more distortion than other driver types. They also tend to sound more full, which you might say might come from the distortion. Some people think it sounds very lifelike and exciting. Generally, they sound warmer. Recent flagship ribbons have a lot less distortion, and they sound a lot more like planar magnetics to me. The whole ribbon is very thin and very conductive. Because of that, the impedance is typically extremely low. And you usually need a special amplifier or some transformer between your normal headphone amplifier and the headphones themselves. Otherwise, you will generally blow a regular headphone amplifier and usually destroy the headphones too. So you have to be very careful with these. Cable types. So I wanted to mention we have a lot of different terminations. I haven't really seen 3-pin mini. 4-pin mini is very, very popular. This is only used for the 600 series for Sennheiser. 3.5 and 2.5 are also very popular. 3.5 is generally more popular, but on smaller, more portable headphones, you might see 2.5. 2.5 long and also 3.5 long barrel, not shown here, can also be popular if you have a headphone with like very recessed like an input. So you might have a very long barrel to get up in there. Then you have some that are basically a 2.5, but with like a special input, because Sennheiser did that. I don't know why. You don't really see these that often. Actually, I don't even know where this one's used. 800 had a special proprietary termination that was frustrating, and then Utopia does as well. And then shown here as well, you have Abyss, which is a 2.5, but it has, you can use it usually a regular 2.5, but it won't sit flush in the cup chassis because they have this kind of this like wedge like part that when you push it all the way in, it kind of sits flush with the chassis, which makes it look pretty. And then for Focal, or DCA, Dan Clark Audio, you have, these are mini XLRs, the 4-pins, but they have a clocking and locking feature. So you have to actually like put it in the right direction, push it, it'll click in. And then when you try to pull, it won't come out. You have to pull the little locking feature, and it unlocks it, and then you can pull it down or pull it out. So it's just a special version of the 4-pin mini XLR. So I'm looking at the time, got like 30 minutes. And then cable types for amplifiers. So these are all the types you would see. 6.3 and 4-pin are going to be the most popular. These are going to be on most, if not all, desktops. And then some desktops are starting to get 4.4. Oh, I should probably explain. 6.3 is single-ended. 4-pin is going to be balanced out. 4.4 is kind of like the more compact balanced out. And then 3.5 and 2.5, you'll generally see those for portable options, either portable headphones, studio headphones, sometimes. Also, IEMs will generally have either 4.4, 3.5, or 2.5. I guess one really important thing to know is there are a lot of adapters. Like you can have an adapter from one type to another type, maybe usually like a pigtail style. But if you have a balanced out, and it's a true balanced out headphone amplifier, what that means is you have left positive and negative and right positive and negative. If you get a balanced out and you create a single-ended out, the negative and the positive, or sorry, the negative and the negative for the left and the right channel will be tied together as if it was ground. If the headphone amplifier was just kind of faking the balanced out because it was like a convenient balanced out, maybe it's like a single-ended amplifier, or it's a single-ended amplifier, and it just has a balanced out for convenience in case like you wanted to use that type, then it won't matter. But quite often the balanced out is a real balanced out. It may not be a balanced out amplifier necessarily, but maybe it has like a transformer in there to create a balanced out. That'll connect and short your left and right channels, and it'll destroy the amplifier. So unless you absolutely know that the amplifier can use an adapter, do not go balanced out to single-ended. Just use the balanced out, or just use the balanced out. That's all I really wanted to say about that. Now we talk about companies, and I have a lot of companies on here, and I probably won't be able to get to all of them, but I'll try. And I also have a lot of technology in here. So going with Odyssey first, it's a US brand. It was recently purchased by Sony Entertainment. which the gaming subdivision, not the audio division. So it's not as cool as I was originally thinking it was. Odyssey almost exclusively makes planar dynamic drivers. They do have one headphone electrostatic. Originally it was the Carbon, now it's the Carbon 2. And they have one discontinued ribbon driver called the LCD-R. I don't know, less than 100 of those I think were made. I think it was like something like 50 or 70 or something like that. And so you might see them on the used market, but they're discontinued now. Odyssey has historically been tuned warm, but the warmth isn't really a bass boost. It's rather a treble relaxation. So you can kind of see that in this frequency response. You see, like I was saying before, planar magnetics all the way down to 20 hertz doesn't really roll off. But then when you look at the treble region, it doesn't really come up for the ear gain. So it has a tendency to be more relaxed in the treble, which taken together makes it sound more warm. But that was true up until about the LCD4, but starting around the LCD5 and the new MM100 and 500, they're not tuned the same way. They wanted to have a more neutral presentation, and so they're tuned differently. Odyssey tends to use the 4-pin mini XLR connectors, this one, except for their like budget and gaming offerings. So really cool things, Odyssey. They have a lot of patents. You can kind of look them up. I did. So these are their phasers. You can see them right here. They look like these little triangles. They sit on top of the magnets. So you have the magnets right here, and you have the phasers right here. They try to act like waveguides. So as you have your sound pressure waves coming off, you have this like diffraction that happens. And what these waveguides are trying to solve is to try to not make that happen, to try to kind of make it more a straight wave coming out. I am going to go through some of these slides really quickly because I have another, where's my slide number? I don't know. I'm probably only halfway and I have a lot to go. So I'm going to go kind of faster. Another thing to note is Odyssey has a proprietary magnet structure. This is using the 3. You have them, the north-south placed parallel with each other. What they tended to do was in between, where the magnets sit in this space in between, it has a tendency to make the magnetic force very flat and basically the same everywhere. But in between, it was also somewhat flat, but in the opposite direction, which wasn't desired. But it was, at the time, they were really trying to make sure that they could have equal force everywhere. So if you can have an equal magnet and you can also have an equal amount of conductivity, you can technically have the whole diaphragm and the whole conductive surface have an equal amount of force, which will push the whole diaphragm at the same time. That's what they were going for. Now, they were kind of showing off what other companies have done in the past. I don't think it's necessarily true anymore, but they were doing in the past where they were putting them kind of in the same plane as each other. And what they're tending to do is in between where these magnets are, on where the diaphragm is, you had this big drop off and it was not even. And so what they're saying is we can do a better job of controlling the diaphragm. And if we can control the diaphragm better, we can have a lot better control of the frequency response and the distortion. Nowadays, they have something they call Fluxer. They started this in the LCD4. They made the magnets still north-south or south-north, south-north. So they're still kind of the same way, but they set them at 45 degrees. They set them together. And so you'll notice that you have still this, magnetic field generated here, but on the top side, it's much smaller. And so what they tended to do is, do I have it on the next page or no? No, I don't. What they tended to do, though, is it made this, they still had the same amount of control between the magnets, but then you had a lot more control in the space between the magnets, which before, like I was showing before, it was going in the opposite direction and it wasn't totally flat. Now they're saying, oh, well, it's in the same direction and it's a lot more flat. So they have far more control, at least the magnetic field across the whole range of the diaphragm. And then they introduced this thing called Uniforce, where where it's not flat, they actually change the voice coil, or the voice coil. They change this, the one that's etched on top of the diaphragm. They can change its height, width, and spacing. So they can change the amount of resistance there, which allows it to, they're able to change how much conductivity. And so if there's any like spots where the magnet isn't as strong or anything like that, they can try to adjust that particular area on the diaphragm itself. And so taken together, they would have what they're calling a universal force, or like a uniforce, where they can actually move the diaphragm as a more flat plate. And then most recently, they came up with something they're calling SLAM. They've historically been trying to create this really deep sub bass by using a very tight seal between the ear pad and the actual like cup. And they've done that with basically a very thin 3mm double-sided tape, which a lot of people have not liked because they can't easily change their pads. You try to take off the pad and it like rips the leather out of the pad or whatever. And you have to, changing pad means destroying a pad. You can't just change it. So what they're trying to do now, they want to increase the bass, but without, increasing the tension on the diaphragm. They've created this bass port. Effectively, it's like a speaker port. It's like porting a speaker, sorry, where they've created this chamber where they're able to actually port and then, give it some bass boost. I assume it's going to be at the cost of that sub bass, which thankfully planar magnetics have that in spades. It's usually really flat. I assume it's going to affect that, but I haven't seen any of the frequency response curves, so I don't know that, but it just seems like it would. Then you have Abyss. They're a US company out of New York. They make high-end open back planar magnetics as well. They have publicly said they don't believe in damping, so all their drivers are very lightly damped. They generally sound neutral bright or warm neutral, and they also offer bass ported pads, which are like they're bass ports like on a speaker. Gives you an extra little bass boost at the cost of sub bass. And they use 2.5 headphone connectors. Big one in the space is Hi-Fi Man. Chinese company, generally speaking, known for their planar magnetics, but they also have some very high-end electrostatics, and they have some dynamic headphones, not popular, but they're in their like the budget space. They also now make their own amps and DACs. The tuning is, you can generalize this, and it's mostly true, neutral bright, and they have a signature dip. So you can kind of see how they don't follow the typical curve, and instead they have this like comparative dip, and then the rise is really high, and then it comes over. For me specifically, I have a tendency to not like Hi-Fi Man because this comes off as sibilance to me. That is not universally true. A lot of people like it. They have this perception of spaciousness, of increased spaciousness. So Hi-Fi Man's kind of like if you enjoy it, you usually really enjoy it. And if you don't like it, you usually really don't like it. It's very polarizing. They usually have very great bass slam, which is something I've liked Hi-Fi Man for. Good resolution. They have great price to performance for their headphones. Hi-Fi Man is extremely popular because of that. However, they also have a tendency to come up with new models and new headphones very constantly. They're releasing I think they released 6 new headphones this year. And so what tends to happen is their resale value tanks, and the used market is usually a much better place to buy Hi-Fi Man. They call their latest drivers nano, referencing the nanometer thickness of the diaphragm. They also might use the word stealth for their magnets. Raw makes ribbon drivers. I mentioned before that the impedance is extremely low. Usually you might see impedances on the order of 15 would be considered low, 15 ohms. And then you might see some like Sennheisers up to 300 ohms. So being sub 1 ohm and like in the hundredths is extremely low. Headphone amplifiers are not made to run this, which is why you typically need either a special amplifier like the Jotunheim R, or you have I mean, Rawl sells their own amplifiers as well. And then usually they now sell this like little transform interface where you plug your amplifier into this and you plug the headphones into this, and it also acts like a stand. And that way you can use your typical headphone amplifiers into this little interface. Meze is a Romanian company. They have dynamic headphones and they make those drivers, but they also have planar magnetic headphones. Those are their more high-end drivers. Those drivers are made by Renaro, which is a Ukrainian company. They're known to be stylish, ergonomic, which is true. They're fantastic. Construction is really good, and they usually feel very premium. Very efficient, easy to drive, tends to be warm. In the past, they tended to be warm, neutral. Nowadays, it's kind of like a neutral, bright tuning. In the past, it used to be quite warm, and then it was very polarizing. Some people really liked it, some people really didn't. And so now they're tending to be a little more neutral, bright. And so the people who didn't really care for them are starting to really like them. And the people who liked them before, it's a polarizing topic in the community. They're lower end headphones, so something like this guy, the 109. Even this is $1,000. So when I say lower end, I don't mean low end. But anyway, their lower end stuff tends to use 3.5 connections, whereas their higher end stuff, we're talking things like in the $3,000 or $4,000 range, tend to use the 4-pin mini. One cool thing about Meze on the higher end things for their planar magnetics is they don't have a typical voice coil. They have this kind of switchback style, and then they also have this like this little round, what do they call it, spiral coil. So the switchback style is for low frequencies, and this little guy in here is more for mid and high frequencies. And they claim that if you do so, you can get a better 3D and spatial localization into your ear canal. Or rather, because it's more pointed at your ear canal, it'll lead to improved 3D imaging and spatial localization. Their magnetic structure falls on top of these voice coils. So they're not the typical like straight bars. And you can kind of see that here. And then you can also see that here, how they're laying the magnets on top. And then their ear pads are magnetically attached. So these guys have a a metal grill, as opposed to usually you'll see a cloth grill. And then that sits on top of the magnets, and it just kind of attaches them, which makes it really easy to do ear pad swaps. Another cool thing is they have very, very comfortable, their ergo on Meze is fantastic. They have very comfortable straps. And because they have this like little wing support system, the pressure distribution is more equal across your head, and you don't really feel any hot spots. They're very comfortable. In the more recent offering, Meze has been licensing AMTS from Dan Clark Audio. I'll explain what AMTS is in a second, but it does allow them to kind of start to filter and like better look at analog EQ on their headphones. I don't know if they're going to continue that for all like new releases, but they did at least do it for the Poe, which was the newest release. So speaking about Dan Clark Audio, often called DCA and formerly Mr. Speakers. Dan Clark started as a speaker designer, turned into a modder of Fostex headphones, and he's now a designer of his own headphones, his own drivers, based out of San Diego, mostly planar dynamic, but they do have 2 electrostats. They tend to be very neutral, occasionally neutral bright, depending on who you ask. They're marketed to be very low distortion. Depending on who you ask, some people consider this to be unengaging. Some people consider it to be very true to the recording. So it's a little bit of polarizing in the community. They are very aerodynamic and they are very resolving. They, like I said before, use the 4-pin mini, but they have their own clocking and locking features, so you need a special cable for it. They have a lot of patents, and I think they have probably the best sounding, or at least, yeah, probably some of the best sounding closebacks. They sound very, very similar to their open back brethren, and so usually you'll hear a closed back DCA and be like, "Wow, this sounds very open." It's generally what people mean. One very interesting thing that DCA does is their planar magnetics. The diaphragm I showed you before, it's like a straight flat piece with the circuit etched onto it. But on DCAs, they have these very deep creases, which they call knurling. And so you see it here, these creases. And what they say is that when the diaphragm generally moves, you have these attachment points. And so you kind of bow, you make a little bow or bow, sorry, and you don't get that like flat diaphragm moving at you because you can't. And then by adding these knurls, they're saying, well, we can have an entire flat piece with only like these corners creating like a small bow. And then we're able to actually have higher excursion from point to point, which means that they could create more sound or more SPL with a smaller driver. Another interesting thing they have is TrueFlow. They have a patent on. It's very similar to what phasers and all the other stuff are trying to do. They're trying to be a waveguide. So, but in this sense, they're trying, instead of creating turbulent flow, they're trying to keep the flow going across the magnet structure to be more laminar. This is to reduce distortion and increase resolution. They also have a patent on their gimbal design, which allows their headphones to collapse, and it's also extremely comfortable. They have what I mentioned before, AMTS, Acoustic Metamaterial Tuning System. This whole thing integrates waveguides, diffusion control, quarter wave, and Helmholtz resonators. This sits between the driver and your ear. And so it effectively allows them to just do frequency, like analog EQ, where they're able to smooth and shape the frequency response, which allows them to hit their target much more easily. They came out with this maybe 2-3 years ago, something like that. I think it's relatively new. I think most of you guys know Sennheiser. It's kind of one of the more notable ones in the space. They have one of the most expensive. This was when I put it together. It was 70,000. This HE1 over here. I heard now it's now 100,000, and then I've also heard that it's becoming discontinued. So I don't know what's up with that. But if you ever had a chance to listen to them, they sound amazing. Usually at Can Jams, the Sennheiser rep will have a sign up. And they're usually that sign up is full within the hour, and you usually get like about 10 minutes to listen to it, and it sounds great. Two important things to know about Sennheiser, though. They sold their consumer brand to Sonova, sorry. So they're still called Sennheiser. So there are two separate Sennheisers. So Sennheiser headphones with the name HD500 or above, so 600s, 700s, 800s are part of the professional division, and they're still part of the Sennheiser that we know. But you need to know that, the consumer brand is not actually Sennheiser anymore. It's Sonova. And then the 500, 600, 700, 800, and the Momentum series are still part of the professional division, and so still part of the Sennheiser, the brand that we know. Nice, cool thing, Sennheiser 800 had this ring driver. I can't really spend a lot of time to talk about it, but it's very interesting. You can read Focal. Some important things to know about Focal. Their headphones are really cool, very stylish. They're French. They have two Utopias. That's their flagship headphones. They started making the new one in 2022. So there's a Utopia OG and Utopia 2022 revision. They changed the tuning. It's a little more warm now, but they also did it because the older drivers on the OG tended to they have very high exertion, and so what might happen is it clipped and it would break the voice coil if they went too far. And so they fixed that on the new ones, but the tonality is different. So if you hear the two different ones, you'll know, but you can kind of, I mean, I kind of explained the differences between the two. You can kind of read, but that's important to know that. The driver in these are actually very interesting. They have this M dome. They have a formless voice coil, and this voice coil fits within this little dome on this ridge, and it allows it to move this whole thing more like a flat plate. And I've explained this a lot so far, is you really want the whole thing to move all as one flat plate as much as possible. And so this is how they kind of try to solve that. It's not showing in here, but there is a video where it shows this driver moving. On the presenter view, it's not showing it, but if you get the actual slides, you can click on it. And then it destroyed where my actual, like, where I wanted it to go, but it shows at 9:19. You can kind of see it. Oh, it's an animation. Well, that's not what I meant to do. But anyway. ZMF, I'm wearing some ZMFs right now. ZMF started as a modded Fostex headphones. Nowadays, they're a well-known company making dynamic and now planar magnetic headphones. They're well known to be like this boutique, beautiful, unique wooden headphones, generally non-warm and non-fatiguing. Guitar, stringed instruments, vocals sound especially good on ZMF. They do limited run woods and stabilized resin sets twice a year during Hot Cup Summer and their November drop. They use 4-pin mini XLR. Some of them are starting to come out with 3.5. That's their like more portable versions. They have a wide range of tuning and pads. So one of the big things about ZMF is you can change the meshes inside to change the tuning, and they sell a lot of different pads. And you can change all these pads to tune the headphone to what you like. So it gives you a lot of different combinations. If you buy one headphone, you have a lot of choices. I was going to talk about this, but I don't have a ton of time. Just know that ZMF also has a lot of cool technology, a lot of interesting ways they handle their closed back and trying to like diffuse the sound, or that like back wave that I talked about earlier. Grados and Beyerdynamic, generally speaking, emphasize treble, and generally characterized as bright. But if that's what you like, or you have, if that's what you like, those are for you. FiO and Dunu, two new, or not too new, but Chinese brands. FiO is like a budget brand, but they make great price performance. They started as DACs, DAPs, and amps, but now they're starting to make headphones, and those headphones are very good. Dunu has historically made IEMs, but their new headphones called the Arashi are extremely good. Fostex, Denon, Yamaha, AT, Final Audio, all Japanese brands. All generally have a neutral to neutral bright tuning, except for the Fostex TH900s, which are very V-shaped. Yeah, that's all I want to talk about here. Also, I had a video here about Final Audio and their like factory tour, and it's amazing how much stuff they do and like how it's actually made. Be careful when you click on this link if you wanted to actually watch it, because the machinery is high pitched, and if you're listening on like speakers or headphones, that is ridiculous. So turn it down first. Stacks, Japanese like electrostatic, tend to be neutral bright. They're a very old electrostatic headphone maker. They do require a very specific voltage offset, so take note if you wanted to get an amplifier that works with them. They generally didn't in the past have detachable cables, but the newest models do. Rawson, very small company. Alex Rawson was the co-founder, or was a co-founder of Odyssey, and then left Odyssey. So the headphones have a tendency to sound like the old Odyssey sound, warm, relaxed upper treble. Head is an AMT company, Head it's a speaker company, but they now make headphone AMTs, error motion transformers. They sound very, very good. They have 3 models. The original is extremely heavy. The 2 latest ones are a lot less heavy, very resolving. I really like the GT. It's a little more of a bass emphasis, and this is more of a neutral emphasis. But I like them both. They're very good. I like the GT especially. And then I have a link here about how the folds are created on the diaphragm itself, which is pretty cool. And then the last real slide I have, Erebus, ETA, HFA, and Modhouse. So all these companies are small 1 to 3 man operations. They've all recently, at least in the headphone space, have gotten a lot of talk because they sound great and they're very good price performance. But they're all small, kind of boutique. Sometimes they have very long lead times. The Sierra Open is, even though it's a dynamic driver, has extremely good sub bass extension. Probably the best I've ever heard. It's fantastic. ETA is very mid-centric, great vocals. They have a new headphone that they're coming out with, the flagship. It's called the Yuli, sorry. I don't know why I said that. Yuli. They're using a new magnetic structure. It was used by speakers back in the day. So they're trying to, use it in their headphones, which I don't think any other headphones on the market are doing that right now. So they claim that it's much better performance. And so I hope to hear them. HFA is a San Francisco-based company. They have this really cool resonator ring inside the ear cup, which lets you change the sound and you get different tunings out of it. It's very, very good. And then Modhouse they do a few different modifications, or they sell their own like modded Fosdeck stuff, but the tungsten's their own design. Very, very good. I love it. It's neutral. They're resolving. I own some. They're great. I did want to talk a little bit about the community. I think some of you guys have asked. I will include it in the slides. But yeah, I organize for the Bay Audio Enclave. I always say that. We like headphones, amps, DACs, like speakers too. Generally, we're more on the portable gear side focused though. I included a link to the Discord if you'd like. Also, if you use your phone, you can get to the Discord this way. And then we have another event coming up, Hi-Fi Con. It's September 28th, and you can find tickets. They are free. And this link, you can get that when you get the slides. I have a bunch of references if you actually wanted to go and look any of this stuff up. I did not want to take the time to put them in every place because it was too many. There are a lot. That's it. So any questions?
Laurie, do you want to go into the chats and read off some of the questions?
Yeah. First, I wanted to say, Vince, did you say how people can access those slides?
If you send them to me, we'll get them out through the Audiophile Foundation. So
yeah,
Great.
we'll make a mailing to all people who registered and send a copy to them.
Great. Yeah, Vince, great job. I have to say, you worked your little heart out. I mean, it was so much information. I'm sure people's heads are spinning a little bit, but the fact that all the slides are available and people can go back and take their time and revisit, what caught their ear in particular that they wanted to learn about. Yeah, I'm thoroughly impressed. A lot of questions during. Steve, you were asking about IEMs and earbuds, and obviously you saw that they didn't talk about that tonight, but that's a really good question, and one I think that we could address at another time, because good God, there's for every
IEMs have even more driver types, and they have tons of different configurations, hybrids, tribrids, they're their own beast. I did not have time for that.
that's a whole item.
We'll get you back for a talk on IEMs, maybe beginning of the year or something like that.
Right. We have a lot of questions got answered. We can thank Brian, Wave Theory, for that. He chipped in and took the time to read the questions and actually answer them very thoroughly. And I'm looking to see if there was anything to do. I say pretty much all the questions got answered.
I
But
think if people feel like their question didn't get answered, they could probably just copy and paste it, and we can see.
right.
What was the question about the balance thing? So what was, let me see. We don't have such a thing as
Somebody
balanced
wanted to know
speakers.
if headphones, if that balanced was actually a thing.
Well, there aren't balanced speakers, so or there aren't balanced headphones specifically. So I mean, every headphone diaphragm is going to be a positive and negative. It's really the question of like the amplifier and the type of connection. So you either have a positive left and positive right, and then a ground as like your negative, or you have a positive left negative, sorry, positive and negative left, positive and negative right channel. And you might have those, let me see if I remember, it's been a minute, but you can have them out of phase, which might like sometimes gives you less noise. And then when they get to the driver itself, I believe it doubles up and you get twice the voltage that way. It's been a minute. I'd have to look into it again. But it's not a balanced headphone. It's more of the amplification and like that signal chain type. Kind of like what Brian was saying.
And wouldn't you say that the primary reason for that is to avoid distortion is the ultimate purpose?
Yeah, so a lot of people do it, or a lot of amplifiers might have it to reduce distortion, reduce noise. A lot of amplifier makers might argue that if you make a really good single-ended, then that won't be necessary. So you'll have some amplifier makers saying like, oh, well, you could have that, but depending on like the amplifier, it may not be necessary. So it kind of depends. It's kind of it kind of depends.
I have a Past Labs HPA1 headphone amplifier. It's the only one that they make, and all it has is a single-ended, and that sucker's beautiful, So
Yeah,
Is it
really well
all
done
right
single
if
endeds
I
are good.
jump in for a moment and
Go for it.
answer this balanced thing? Okay. My camera's not on either. First of all, thanks Vincent for that presentation. That was cool. Hey everybody. All right. So the balance question is interesting and I think particularly confusing when you move into the headphone space from the speaker space. My impression is that in two-channel audio, single-ended connections dominate everywhere. At least they have historically. In the headphone space, things have gotten a little bit different because computers became a very, very common audio source with music files and all of that thing. Well, computers are very, very noisy, like electromagnetically noisy. And if they are connected to a DAC via like a USB connection or something like that, then they can, some of that system noise can bleed into the audio signal chain. A balanced signal path is much better at rejecting that noise than a single-ended signal path is. USB connections have gotten better at rejecting this noise, so it's becoming less and less important to have a balanced signal path. But there is inertia in markets, and the name balanced just sounds better, right? You think balance is like that sounds correct, that sounds good, that sounds desirable, right? So what really has happened is like balanced DACs and headphone amps have started to dominate in the headphone space. I have my own issues with that, but that's what's happening here. So we're not talking about the drivers of a headphone or a speaker being balanced or not. It's it's the source chain, right? The DAC, the amp, okay, whatever you got there. And that's where it matters to be balanced. Now, Vincent's point in there earlier was very important. You do not want to plug a single-ended cabled headphone into a balanced output of an amp, because a balanced amp is like two completely separate amplifiers almost inside the same box, right? And so they are both designed to have like a positive and a negative connection, and then the two amplifiers, one for each channel, basically just don't talk to each other at all. Where in a single-ended design, the return signal of each is tied together. That's why, like on a quarter-inch phono plug, okay, you'll see 3 electrical contacts: the tip, the ring, the sleeve, and that's because the return channel of both is tied together. But if you do that to a balanced amp, you connect the two negatives of two things that were never meant to be connected to each other, then you can cause some problems. Like you can get some shorting and all of that, which is why you need to be careful there. So no, headphones are never balanced on their own. Just like a speaker driver, you just have two terminals, one labeled positive and the other labeled negative, but because it's all AC, they both spend equal amounts of time being the positive and the negative, right? It's in the signal chain though. Like that's where the balance matters. That's where the noise rejection that we really worried about once upon a time was important. And then yeah, anyway, I'm probably rambling now. Does that answer the question to whoever had it?
Great, Brian. Thanks.
Yeah.
I got a question for Vince.
What's up?
Is there any, it's obviously going to be, as you said at the very beginning, really listener to listener, preference, but are there certain types of music that tend to gravitate to specific types of headphone design?
Sure.
Like people who only listen to classical tend to listen to blah, blah, blah. And people who listen to headbang and rock tend to listen to this, not brand, but this
Type
design.
of driver, yeah.
Yeah. Can
I
you
mean,
a little bit?
so I mean, tend to listen to classical, jazz, even maybe. You might go electrostat, because I mean, if you're going to listen to classical, you're going to listen to jazz. You may not care so much about deep sub bass, that kind of thing, and you generally want something extremely resolving, extremely microdynamic. You might do something like that. And then if you want to listen to, let's say, rock, metal, depending on your preference, you may go something dynamic. If you want something a little punchy, but then if you care more about like bass, it's going to be a toss up between dynamics and planar magnetics.
Okay. Someone asked what are your top 3 favorites? Headphones.
Right now, the Artur Classic, the ZMF Artur Classic, is just a really warm, well-balanced, not extremely resolving, but really good casual listen. I really like it. Really like it if I'm not looking to examine the music, for example. I just want to enjoy it. Love the ZMF Artur Classic. I recently got the Caldera closed. I really, really like it. It's very fast, very resolving. Really, really loving the Mod House Tungsten. Just fantastic headphone. Again, another planar magnetic, really resolving. Does basic sub bass extension very well. I really enjoy it. But then again, for very, very casual listening, not technical, for my bass heads, I love. Let me get you out of here. The old OG Meze Imperium. This is not for people who are looking for extremely resolving. This is just fun. This is bass head fun, and I love them.
Good question here for you. Is it okay to hook up headphones to a speaker amp like a 300?
Depends on the speaker amp. So sometimes yes. In fact, like the tungsten would be pretty good to hook that up to. Even the Susvara would be pretty good to hook that up to. However, that's not always the case. Sometimes you need an adapter. Some speaker amps don't tolerate that really well. They're looking for a 4 or an 8 ohm load. And you might need a little, like a converter. Yeah, like that exact converter that Wave Theory just put down in the chat. In which case, I think pretty much anything, if you have a converter box like that, can be used, I think. But some speaker amps tolerate it much better than others. Don't use that with an amp that has an output transform. Fair. Yeah, so it'll definitely vary speaker amp to speaker amp. Some speaker amps you don't need to do that. I mean, I've had examples, but I don't have any good examples right now. But
generally, the harder to drive stuff, like what he was just saying, the tungsten and the Susvara, mostly you can just plug those directly into a speaker amp. And in fact, many cable makers will make cables that have either spade plugs or banana plugs on the amp end, and then will go to like right into the headphone of your choice there. But again, you want harder driving, power hungry headphones to plug into a speaker amp generally. Because speaker amps usually put out a whole lot more power than most headphone amps or most headphones are going to handle. Short of that, then yeah, look at one of those like external transformers like the one that I linked to or something like that.